video is going to go over part 1 of the Unit 9 review, which is the part where you got the DESMOS graphing calculator. Okay, so I'm not even going to write a single thing down as I go through this review because it can all be done in DESMOS. Yes, you can do this algebraically. Yes, I have shown you in the notes and in the practice, you should have been practicing doing this algebraically, but I'll show you algebraically on part 2, which you don't get the calculator on. But I just want to emphasize and point out that 50% of your tests, which is 50% of your review, can be done simply in DESMOS. So there's no reason to make less than a 50 on this test. Okay. So when you're asked whether it, like this one is addition, there's addition, division, subtraction, more division, okay, and factoring. Okay, so all of these questions I'm going to go through and just show you in DESMOS. So if it's just simplify, all you need to do is work backward because these are all multiple choice. You can work backward from your choices here and plug these into DESMOS. I'm going to get a separate window for DESMOS so I can split screen this with you. Here. Okay, so you're going to put in the expression that's given to you. Okay, so I'm going to start with a divide, so it makes the fraction. So this is x over x squared minus 9 plus, and then another division. So 3 over x minus 3. Okay, so this is what's given, and I can see the graph over here. Then I'm going to start with my first answer choice A over here, and I'm going to see if it's the same graph. So I'm going to put x plus 9 over x squared minus 9, and you can see the red and the blue separate. So those are not exactly the same. Okay, looks like some of the parts are similar, but they're not identical, they're not equivalent, so it is not that answer choice. So then I look at the next answer choice, which is 1 over x minus 3. Okay, again, some similarities, but they are not exactly the same. So that's not it. So then my next answer choice is x plus 3 in the numerator and x squared minus 9 in the denominator. Again, not exactly the same. So it must be this last one, but I'm going to show you just to double check. So we've got 4x plus 9 in the numerator and x squared minus 9 in the denominator. And you can see that those are right on top of each other. That's the exact same graph over here. So that's it. That's the choice that's equivalent. Okay. So then with number 2 says if no denominators are equal to 0, which is equal to this expression. So that's just another way of saying we know the denominators can't be 0 because you can't divide by 0. Okay, it's just also asking us to simplify this. So my original, I'm going to change to 5 over x squared minus 3x minus 40. And then it's plus, and then that numerator is x plus 1, and the denominator is x minus 8. And then that first answer choice is x plus 6 over x squared minus 2x minus 48. Okay, so I can see over here in the graph, those are not exactly the same. That's two different graphs. Okay, so that's not the answer choice. So then I check the other one, x plus 6 in the numerator, and then it needs to change my middle term to a 3x, and then my constant to a 40. Still not the same, so knock that one out. Okay, so this one has my numerator as x squared plus 2x plus 6, and my denominator x plus 5 times x minus 8. Ooh, those are much closer, but you can still see a difference. They are not identical, so that's not it. Okay, so then I check x squared plus 6x plus 10 in the numerator and x plus 5x minus 8 in the denominator. And then you can come over here and turn that on and off and see those are the exact same graph. So that's the one. Okay, now this one is division. Now here's where it may look tricky in DESMOS, because when I change this plus to a divide, notice that's what it does. Okay, so it makes it look kind of messy. So instead, I'm going to put my entire first expression in, that's supposed to be parentheses, come on, in parentheses. It's not a question mark, just a parenthesis. Okay, and my entire second expression in parentheses. Okay, now if I change that plus to a divide in between the parentheses, well, I don't know why it didn't move that to the denominator. It should put this in the denominator. If you were typing it this way instead of editing what's already typed, it would work better. So you can type your first expression, which ours is 2x plus 3. Okay, close parentheses, and then divide. And then in parentheses, you can put your second rational expression, which here is a quotient. So I'm going to put x squared minus 4 over x plus 2. Okay, so you can see I have the first expression divided by the second expression. So that's what I was originally given. And now I'm going to check my answer choices to see which one of these is equivalent. Now, some of you should, most of you should be able to actually answer this question without DESMOS if you think about it, because it's not asking you to actually solve all the way. It's just asking what's the next step. So when we have division of rational expressions, we talked about dividing fractions as easy as pi, flip the second and multiply, okay? Or that phrase, keep, change, flip. Keep the original expression how it is, change the operation from division to multiplication, and flip the second expression. So this fraction, I need to get the reciprocal. I need to flip it upside down. So if you look at your answer choices, 2x plus 3 should stay as is, which this answer choice has flipped the first one, and I know that's wrong. You don't flip the first one. That one flipped the first one, that's wrong. Okay, so this one kept 2x plus 3 as the numerator, that's good. So did this one. Okay, so I've narrowed it down to 2 answer choices already. Okay, they're both multiplication. Okay, so far so good on both. They kept the expression, the first expression, they changed the operation to multiply. Now which one flipped the second expression? That one looks exactly the same as how it was given. So the only thing that changed here was the operation. They forgot to flip this fraction, so that's out. So this is the one that flipped that second fraction. So if you need to type that in and compare it and see that it's the same graph, you can. But if you just remember for division, keep, change, flip, okay, you'll be able to answer that. This is the same thing. It's division. What's the next step? So you just need to remember, keep, change, flip. So I need to keep 3x minus 1 as the numerator. So those first two are out. Change to multiplication. They both did that. And flip that second one, which is this answer choice. Okay, in this one, y'all have a good one. I'm going to keep finishing the video. Y'all can check it later if you need to. In this one, which expression is equal? This one goes ahead and solves it out. So you keep, change, flip, and then multiply it out and reduce if you can. So this one would take some algebraic steps written out, or you can use your calculator and work backward from your answer choices. So this time, the first expression is a division. It's a quotient. Okay, so I'm going to type in there. Now, the other thing is, these are y's this time. In DESMOS, when you're typing these in, it has to be x's. You have to use x's as your variable to see these graphs. So you put a fraction in a fraction here. Okay, so the first one, the dividend is x over x squared minus 9. Okay, thank you. And then the second one, what we're dividing, the divisor, is 3 over, and then again, we're using x's instead of y's, so it's x squared plus 9. So that's what we're originally given. Okay, it's going to be written like a division, like a fraction, instead of seeing this division symbol in DESMOS. And then you just check your answer choices. So this one has x squared plus x over x minus 3. Those are not the same graph, so that one's out. So then, okay, x squared plus 3x over 3x minus 9. Not the same graph, that one's out. And then this one's got x cubed, so change that power, plus 3x over x squared minus 9, not the same graph. So it's got to be this last one, but we'll double check it. X cubed plus 9x over 3x squared minus 27. And now you can see those are the exact same graph. Okay, so that's the one there. Okay, so that's half of the review already done in like 5 minutes or however long this video has been. It's not very long. Okay, which of the following expressions is equivalent to this? Now this one's a subtraction, so we do this one just like we did the addition ones before. Okay, so let me change my first expression is 6 over 3y. And again, you can't type y's. You do have to use x's in DESMOS, so it's 3x minus 9. And I'm going to make that a minus. And then my second expression is 1 over x minus 3. Okay, so that's what we're given, and we want to know which one it's equivalent to. So I'm going to check this first answer choice, which would be 1 over x minus 3. And look at that, first shot. Those are exactly the same, so that's it. Okay, this is another division one. Okay, so you'd have to go back to setting this up as the quotient. So let me type in the first expression. The numerator is x plus 2 times x minus 3. And again, I'm not saying you have to work backward from your answer choices. You could totally do these algebraically by hand. But I want you to see that you can use DESMOS on all of these, so at least to check your answers. Maybe do them algebraically by hand if you want to, and then check that you have them right using DESMOS. There is no reason not to check them and get them right, because DESMOS will show the graph matches if they're equivalent. Okay, so I did that divided x. Okay, so we get this parabola. So now my first answer choice that I want to check is x minus 3 times x minus 2. Whoa, I've got a lot of extra stuff in there. Okay, turn that graph on, and it looks like that's the exact one. That's the same graph. So that's it. Okay, you could check these others, but they're not the most simplified versions of this. Okay. Now let's see. No, that one's not it. I was going to say it's possible that they'd be equivalent and just not completely simplified, but I don't think there's any like that. So that's the answer choice there. Y'all, I'm just finishing up this video, so y'all just ignore me for now. Okay, so here's another division one. Now this, you should be able to do this by factoring and reducing your fraction. But again, you don't have to. If you want to set this up in DESMOS, this one is x to the 4 minus 25 over x squared minus 5. Okay, and I say over because it's division. And then your first answer choice that you want to check is x squared minus 5. Those are not the same, so that's not it. So then you say, okay, what if I change that to +5? Oh, look at that. Those are identical. That's the answer. Okay, and then I move on. Guys that just came in, I'm just finishing up this video for Algebra 2. Give me 1 sec. Y'all go ahead and get your notes packets out for Unit 11. Okay, so back to the video, sorry. So those two were the same, I got that one. So here's this next one, number 9. I've got this expression and it says divided by. This is one, ideally, algebraically, you could do synthetic division. But again, you don't have to, okay? If you've forgotten how to do your synthetic division, how to set it up, you can write this in DESMOS like this. So this is my dividends. I put in the numerator, and then my divisor, x minus 6, would go in the denominator. Okay, and then I would type out which of these answer choices I want to check. So this one is 2x to the 4 plus 4x plus, and then it's 5 over x minus 6. Those are not the same, so that one is not it. Okay, what about +5? Close. Not it though. Not exactly the same. Okay, so, oh, let me double check. That one, sorry, that one was 2x squared. So let me change that to a 2x squared. So 2x squared, and then it was minus 4x plus 5. So no, that was not it. Okay, so 2x squared, let's change it to plus 4x plus 5, and that one is exactly the same. So that's the one that I would select. Okay, and then the last question, factor. Okay, again, you're not asked to solve, you're just asked to factor. This is a sum of cubes. You should be able to use the formula for sum of cubes to do this one. You can't, this is one that you can't do like we were doing all those others, just because it's got two different variables. See how I have B and A? So let's see if we use X and Y, if it'll work. I haven't tried this one in DESMOS, but we'll give it a shot. So let's use X and Y instead of B and A. So I'll use X cubed plus 125 Y cubed. Okay, we want to know, but again, you're going to have the formula for sum of cubes. And if you look at your answer choices, you'll be able to eliminate some of these right off the bat. Like the formula will let you look at the signs, just see that you have the signs in the right place. Like see how this first one in the second expression is a minus, and this one's a plus. And then you've got a couple lines. You'll be able to eliminate things like that if you just look at the formula of how it's supposed to work out. But if we're checking them, let's see if this will allow us to check this way. So I used X for B and Y for A. One, two, oh. Right, there we go. Yeah, so see how we got the way this, try adding an equal sign to turn this into an equation. It's not going to graph this for us with the two variables, the way that it's written, the way that they give it to us. So this one is the only type on this with the graphing that it doesn't allow you just to graph it and compare graphs. Okay, so again, on this one, I would simply eliminate answer choices using the formula. And again, your formulas are on the purple reference sheets that I gave y'all. As long as you have your purple reference sheets, you'll be able to use those. And they're in your notes here. Let's see, special products notes. This is the very first set of notes for this unit. Here was sum of cubes. So if you have a perfect cube plus another perfect cube here. Okay, this is how it's supposed to expand out or factor out. So you would take the cube root of each of those and have the sum first. So look at your answer choices here. Okay, so the cube root of these, and on that formula, the reference sheet that I gave y'all that has these formulas, it also has a list of the perfect cubes. So 64's cube root is 4. So it should be 4b plus, and then the cube root of 125 is 5. So then it should be 5a. So it should be 4b plus 5a. So this one has those squared, it's out. 4b plus 5a. Okay, so we've narrowed it down to 1. Okay, and then if you go back and see, okay, after I have that trinomial, I should have the a term squared minus the a term squared and then a minus. So if you go back and look at this, okay, your a term, when we took the first term, the cube root, we said should be 4b. So you should have 4b squared. But 4 squared is 16. This only has the b squared. It didn't square the coefficient, which it should have. So this one's out. This one, right away, you can see it's out because it has the wrong sign. It's supposed to be a minus right here. So this is the only one that has that entire term squared. So the 4 squared becomes 16, and then the b squared. And then it's got a minus in the right spot. Okay, so I just used process of elimination, looking at the formula of how this should expand out to see that it should be that one. Okay, so that's the part 1 of your review, and that's very similar to how part 1 of the test is going to be. So there's really not much of a reason that you should get any less than a 50 on this test, even if you can't do the algebra or remember the steps, because the majority of that can be done in the calculator, the great 90% of it. And then that last one can just be use the formula chart that you get, the reference sheet, and just eliminate answer choices that don't fit the expansion of that equation.